let's do these 6 integrals. So the first one is the integral e to the u divided by 1 minus e to the u square du, which what is the u? The u is 1 minus eu because 1 minus eu is inside a square, right? So you let u equals to, oh, by the way, the u is already used. So let's use something else. So other than u, what can we use? Let's try a w, shall we? Let's try a w. W equals to 1 minus eu, and then dw, the derivative of 1 is 0, the derivative of e is always e, and then w, dw, right? Oh, du, sorry, du. Du, and that is not w either, so that is u, and then 1 divided by negative eu, dw equals to du, and then we do a replacement. We replace the du with this. So we replace that, and now we have the integral eu, and then that is w squared times 1 over negative eu, and then dw, right? And then we can do a cancellation of the e to the u. So now we have the integral negative w to the negative 2, and then dw. So that is equal to negative 2 plus 1 is negative 1. 1 divided by that, so the negative sign is cancelled. And then we add c to it. So what is w? W is 1 minus eu. So we have 1 minus eu to the negative 1 plus c. For the negative exponent, if negative exponent is not allowed, then you have to do 1 divided by 1 minus eu plus c, depending on the preference of the problem. When you do homework online, you have to pay attention to this. Sometimes they do not accept negative exponent, but in my class, for the written homework, written quizzes and exams, I accept negative exponents. So that's the first one. Let's try the next one. So the next one is, I have to go back up to see what the problem is. So the next one is integral of what ln x square dx, dx, x divided by x, dx, since ln is inside a square, so we let u equals to ln x, and then du is equals to 1 over x dx, and then we have x times du equals to dx, and then we have to replace the dx with x times du. As a result, the x will be cancelled. With a little bit of practice, you can do this step in your mind, which is what I strongly recommend you to do. X times x du, and then you are able to get rid of these two x, right? With a little bit of practice, you can do this in your mind, and then now you can quickly integrate that. So that is u to the third, 2 plus 1. So 2 plus 1 is 3, and then 1 divided by the power plus c, and then you have 1/3, and then the u is ln x, so ln x, and then raised to the third plus c, and then there you go. So since you have an ln, you have to specify that x must be greater than 0. Okay, so that is number 2. And then number 3, let's move up to top so I can see what the problem is. So number 3 is the integral of secant square theta times tangent to the third theta d theta. Wow, this one you might have a little bit trouble in finding what the u is. So I prefer to let u be tangent. Can you let u be secant? If you can solve the problem, yes, you can let u be secant. So maybe I'm going to let u be tangent right now. Maybe after you are done, you can also let u equals to secant to see if the problem can be solved. So I'm going to let u equals to tangent theta. Then du, the derivative of tangent, is secant square. That's why I let u be tangent, because I can cancel the secant square completely. That's the purpose. And then 1 divided by secant square theta is, du is equals to, forgot the d theta. D theta, and then you do a little replacement. You replace this with the d theta, right? So you have integral secant square theta times u to the third times 1 divided by secant square theta not d theta, du Let's change that. So that is a du, and then we do a cancellation, get rid of the theta, and then check your integrand, make sure there is no more theta. So that is the integral of u to the third du, simple power rule. 3 plus 1 is equals to 4, and then 1 divided by the power plus c, and then now you put the u back. So 4, and then u is tangent, right? So that will be tangent to the fourth plus c, or you can put the fourth power between the tangent and the theta. So that is number 3. And then number 4, let me go back up so I can follow the color code. I use blue. Okay, so number 4, that is the integral of x squared plus 1, and then x to the third plus 3x to the fourth dx. Alright, since x to the third plus 3x is inside a fourth power, I would like to let that be u. So u is equals to x to the third plus 3x, and then du is equals to 3x squared plus 3, and then dx, put the x on the left hand side, 3x squared plus 3 du, that is equals to dx. Alright, but the thing is, the 3x squared plus 3, that is not going to get rid of the, look here, this is not going to get rid of this. What should I do? Look, we have to factor out the 3. So 1 divided by 3, x squared plus 1, now this will work, du, and then dx, and then you replace this dx with this piece. Alright, let's do the works on the right. So we have the integral x squared plus 1, and then times u to the fourth power times 1 divided by 3 times x squared plus 1, and then du, and then you can do a cancellation, cancel this with that, and then check your integrand, no more x. So now we are safe to proceed. For the 1/3, you can just bring the 1/3 out. If you want to keep the 1/3 inside, that is fine. And then we use the simple power rule, so that is u to the fifth, right? And then we have a 1/5 times 1/3, then that will be 15, and then plus c, and then you put the u back, so that is 1/15. The u is x to the third plus 3x raised to the fifth plus c. So now this is done. Moving on to the next integral. Let me go back up to see what color I use. I use green. Oh, actually that was the fourth problem, right? So the one that I just solved was the fourth problem. So the next one is supposed to be pink. So the pink one, I'm going to do the last one. Let me make sure 1, 2, 3, 4. I have 6 integral. 1, 2, 3, 4. Oh, actually, you know what? I solved the multiplication. So that means I still owe you this one. I still owe you this one. Okay, let me just do that one. Which one should I do first? Let's do the 5 to the x power first, and then I will go back to do the e to the x. All right? Okay, so stay tuned. I will do that one for you too. So this, we have the integral of 5 to the x power, and then sine 5 to the x power dx. So we have 5 to the x inside a sine function, so we let u equals to 5 to the x. That's why I picked this problem. What is the derivative of this exponential function? That is 5 to the x ln phi dx, and then 1 divided by 5 to the x ln phi du equals to dx. And then you do a replacement. You replace this dx with this. So what do you have? You have the integral u times sine of u, right? Sine of u, and then the dx is 1 divided by phi x times ln phi dx. And the next reason I picked this problem is because you are not able to get rid of the phi x, but the phi x, you already let the phi x be u, right? So this one, there are two ways to handle this. You either replace this with phi to the x, so you can cancel. After you cancel that, there is no more x. All right, so let's go ahead and take this out, ln phi, and then the integral sine of u du, and then you integrate that. The integral of sine is negative cosine, so you have a cosine of u, you can put the negative in front, ln phi, and then plus c, and then you can now replace the u with phi to the x, so that is negative cosine phi to the x divided by ln phi, and then plus c. So that is the, I think it's the sixth integral, right? I still owe you another one. So we solve this, and the multiplication one, so we just solve this, and then we solve that. Now I need to do this one for you. The integral of e to the x times the square root of 1 plus e to the x. All right, let's do that. I'm going to switch to that color. Okay, let's do that right here. So we have the integral of e to the x, the square root of 1 plus e to the x dx. So we let u equals to 1 plus e to the x because that is inside a square root function. Take the derivative of that, and then 1 divided by e to the x du equals to dx. So that becomes e to the x square root of the u, and then times 1 divided by e to the x dx, and then you can get rid of the e to the x. So you have a simple power rule, and then you take that, you add 1 to it. 1/2 plus 1 is 3/2, and then 1 divided by 3/2 is 2/3, and then you add a c to it. So you have 2/3. The u is 1 plus e to the x raised to the 3/2, and then plus c. So if you are doing homework online and they do not accept rational exponent, you have to put that back to radical, like this. 1 plus e to the x to the third power plus c. If they do not accept rational exponent, that means the exponent cannot be in fraction. All right, so that is the last integral in this lesson. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. See you all in the next lesson. Signing off for now.